All right, in this lesson, we're going to talk about the equation of the locus. So we have this example. We have a point xy is always twice as far from the x-axis as it is from the point Q, which is given by the coordinate 0, 3. We're going to find the equation of the locus, P. What it means is that basically we want to know what kind of a pattern this P is creating based on this given condition, and hint hint is going to be one of the conics. All right, let's look at it. The first thing we have to do, we have to set it up. So we have the coordinates that we have to figure out. First of all, the idea that the coordinate is from the x-axis, we need to know a random coordinate on the x-axis is always x comma 0, because it doesn't have a y value. So the y value is, well, it does have a y value, but the y value is 0. And then we have the point Q that we have to work with, and then we have the point P that is actually moving around based on this given condition that is twice as far away from the x-axis as it is from the point Q with 0, 3. All right, so the first one is the distance of PQ. Let's find out what that distance is, and we're going to use distance formula. And remember, the distance formula between any 2 point A, B is given by square root of x2 minus x1 all squared plus y2 minus y1 all squared. Basically Pythagorean. That's what that is. All right, so let's set it up. We have the 2 points. First is between P and Q. And now remember, P and Q, x and y, and 0 and 3. So this would be x minus 0 all squared plus y minus 3 all squared. All right, so that's the first one. And then we simplify that. This becomes the square root of x squared plus y minus 3 all squared. That's the distance of PQ in terms of x and y. To make it simpler, let's label the coordinate x0. Let's label that as point L. So now our next step is to find the distance between P and L. So we're going to go through and we're going to use the same thing, but this time, remember, we are using the same x and y for the coordinates of the P. So these are the 2 points we're using, x, y for P, and L is x0. So this is L, this is point P. We're going to plug that in. So it would be x minus x all squared plus y minus 0 all squared. Simplify that, we get the square root of y squared, which is equal to, well, actually, we're going to leave it like that. We're going to leave it like that. So our next step is to write the equation based on this condition that is given to us from point P and x-axis and the coordinate 0, 3. So point P is twice as far away from the x-axis as it is to the point Q. So the way you write it is that you write down 2 PQ. That means 2 times the distance of PQ must be equal to the distance of PL. That's what it means, right? So if that's the case, we're going to rewrite the whole thing now. We're going to write 2 times, and we know what the distance of PQ is because we just found out what PQ was right there. We have this right here. So we're going to rewrite that at the bottom. So that would be x squared plus y minus 3 all squared equals to, and PL is the square root of y squared. Excellent. Now we're going to go and solve and simplify. We're going to get rid of radicals. So we're going to square both sides of the equation. So the first thing we're going to do is square both sides of the equation. All right. And and then we simplify 4, and then this becomes x squared plus y minus 3 all squared equals to y squared. Okay, once we raise both sides to the power of 2, we're going to get 4 times this bracket equal to y squared. We are going to expand the middle term, y minus 3 all squared, and that should give you y squared minus 6y plus 9. That's a binomial expansion. The right hand side stays at y squared. We're going to multiply the 4 into the bracket, one term at a time. Here it is. That's what we're going to get. Okay, so one term at a time, you're multiplying this through. All right, once you multiply through, you will get this value right here, this equation. We simplify the equation, collect like terms. The constant goes to the other side, y squared. We subtract y squared from both sides. You're going to get this. And then remember, we need to find the equation of locus. And when the equation of locus has to be in standard form. So we are factoring 3 out of the two middle terms, not 3y, even though the GCF is 3y, but we are going to just factor 3 out. We're going to get y squared minus 8y equal to minus 36. And then we need to use the completeness square method to actually make that into a standard form and then find the equation of locus. Here is what you do. So we rewrite the first term. The second term is that, but remember, to complete the square, we take the half of minus 8. Okay, half of minus 8, and the squared we add. Half of minus 8 is minus 4, squared that is 16. And now, whatever we add to one side, we have to add it to the other side. But be aware that you're adding actually 3 times 16. So in this case, it will be minus 36, and then will be plus 48. Whatever we add to one side, we have to add to the other side. So that's what you will get. And then when you simplify, the last step will end up being 4x squared plus, and then you get 3. I'm going to factor that, and that becomes y minus 4 all squared equals to 12. And then once you get to that, you divide everything by 12. Okay, and then the next step, you divide everything by 12. Final step, and then we simplify. X squared over 3 plus y minus 4 all squared over 4 equals to 1. And if you see that, that looks like a standard form of equation of ellipse. So the locus is an ellipse, and center of that is 0, 4. That is the equation of the locus.